So this is a hard problem that involves a force applied at an angle. So it says that Marcia is pushing down to the right on a 10 kilogram box at an angle of 30 degrees below the horizontal. The box slides at a constant velocity across a carpet whose coefficient of kinetic friction with the box is 0.70. Determine the magnitude of the force exerted by Marcia on the box. Well, the first thing I'm going to do is draw a force diagram. Now, in drawing this, the force of gravity is easy enough, and we actually know that. If we assume G to be 10, we can assume that the force of gravity on the box is about 100 newtons, or it's also, it would be like 98 if you were using 9.8 for G. While you may not know exactly the force of the normal force, you would be aware at least it would be greater, because Martha is pushing down at an angle. And so what that would do is you would be pushing down on the floor an extra amount. Okay, so I've labeled a little bit more here. So I've got the pushing force broken apart into its components, calling those FPX and FPY. And then I also wrote the force of kinetic friction over here. So now we can start solving. Okay, the next thing we need to think about is writing the sum of the forces. Now we know the box is moving at a constant speed, so that tells us that for both the x and the y direction, sum of the forces will be 0. So for the y direction, there's the upward normal force, and there's the downward force of gravity, and there's the downward component of the pushing force that I'm calling FPY. And in the x direction, there's the force of kinetic friction to the left, which is offset or equally balanced by what the component of the pushing force that I'm calling FPX. And somehow or another we have to figure out the magnitude of the force exerted on the box. Well, in looking at this situation, I can easily see that Fk equals Fpx, and I can see that the Fpy and the Fg added together would be the same size as the normal force. Unfortunately, I only know the force of gravity at the moment and the mass of the box, and I also know that this angle is 30 degrees. Okay, so I'm going to have to do some very clever physics and algebra to arrive at a correct answer. Maybe I shouldn't call it very clever, but it'll require a small amount of thought at least. Okay, so I'm going to do a little bit of algebra with this. I'm going to move this over. And set it, make sure I make this negative, and this one would also, yikes. Not sure why that erased, but we'll go with it. All right. Alright, so now I'm going to plug in some stuff that I know here, at least one thing I know. So the FPY, if I did some trig with this, the FPY would be equal to the just the regular F push. It's a Y component, it's opposite side from the angle, so that would be sine of the angle. Okay, and that equals the normal force minus the force of gravity. Okay. Something else I know is that rearranging the sum of the forces from the other side over here, or for the x direction, I know that the force of kinetic friction would equal Fpx, and I'd have to make one of those negative, so I'm going to make the Fpx negative. Alright, and with that, I know that the force of kinetic friction actually equals mu k times the normal force. And I know that the Fpx would equal, alright, the Fpx, I could replace that with just the Fp, and this time Fpx, it's the cosine of the pulling force, or cosine of the angle anyways. Alright, so now that I have this, I can divide by the coefficient of friction on both sides of this green expression, or green equation. And now I have something that I can plug in for the normal force over on the other side. So I'm going to carry on with this equation. So then I have Fp sine theta equals, okay, looks like those two negatives are actually going to cancel out. Almost forgot to divide here. Don't want to forget that. And then I'm going to rearrange so that I can get Fp on all together, or my Fp's all together. Alright, and we are getting dangerously close to having something that we can solve for. Move the screen down a little bit. So now I'm going to move this term over to the other side. I'm going to pause it while I'm writing the rest of it. Alright, and now I can go back and plug in the stuff that I know. So it's going to be the negative, the force of gravity. I'm going to call that a negative 100 because it's pointing down, and that's how I set up my coordinate system. So it's sine of theta, which is really 30 degrees. By the way, y'all, make sure your calculators are in degree mode when you do this. Cosine of 30, and divide that cosine by the coefficient of friction, which was 0.70. Alright, time to do some math. And looks like when I put all that in the calculator, I got about 136 or so newtons for the pushing force. And that seems like a reasonable answer if we look back at our original force diagram. So we'll go with that. If you wanted a more precise answer, just a reminder, you could use 9.8 for G. So instead of 100 newtons here, you get 98 newtons as the force of gravity. And that's how you would work out this problem. Hope you enjoy it.